Hello, my name is Roman, and I'm working with Saud and Tyler. And for our project, we built a model to replicate the motion of the Earth orbiting around the sun. So the design originally came from another project I was working on for a different class, where we had to design a solution for a natural disaster and create a model of that. And I was using my old Legos for this model, and I really needed a sphere with a Lego attachment, but those don't exist. And then when this project came around, I really wanted to make that Lego sphere again because this project involved Legos. And then I thought about how to incorporate a sphere with Lego pieces into this project using gears. And then I came up with the idea of having a model of the Earth revolve around the sun. My original idea was to have the sun be stationary and have the Earth move around the sun on a separate track independently. However, this changed due to the complexity, and then I eventually decided to build a model using the Legos to get a feel for this design, and I based my project on that. And here is the original Lego model I built, and we're going to play this video right here.
Hello, my name is Saud and I'm working with Sohan and Tyler. Our project has 10 parts in total, consisting of 2 gears, 1 crank, 1 main axle, 1 small axle, 2 large half spheres that are glued together for a full sphere, 2 small half spheres that are also glued together for a full sphere, and 1 base plate. The base plate will hold everything in place. First, the big gear will slide into the main axle and the main axle will be placed on the base plate on the same base plate. On the side, it will have 2 supports sticking out to hold the same gear. And at one end of the supports, the crank will be attached there to rotate the gear, and that will rotate the other gear. Then on the other side of the main axle will have a hole, and that's where the small axle will go. It will be screwed in the main axle. Then at the end of the main axle, you will screw in the sun sphere, and the second axle you screw in the earth sphere. So you could see right here of how everything is assembled. The crank will be attached to the gear, and the gear will be attached with a base along with the crank, and the gear will be rotating the other gear that's on the main axle, and the main axle will rotate everything else while being on the base plate. The sun will be screwed onto the top, as you can see the shaded spot right here, and the earth will also be screwed on top right here also. Every single part that you see that's shaded, like here, here, and here, is going to be where you're going to screw in the parts. This is the abstract of the project. This is where we have the proper name of the parts, the description, who's building what, and the dimensions of it. For example, my part was to do the main axle, and it tells also there on the very right of what the measurements are.
So here is the base plate of the part where it has the center part right here, which connects to the main axle, and the supports that allow for the crank to move around. And then here is the crank right here. And then here we have the earth piece. So I wanted to have the earth piece like a full earth, which I also created right here. But in terms of 3D printing, it wouldn't print properly, so I decided to make a half earth and then just print this part twice. And here's the sun. Then here is a full version of the sun piece. And then here is our main axle. So right here at the bottom is where it would insert into the base plate, and then this top part would go into the sun. And then right here, this little attachment piece was where the earth axle would fit in. So here's that earth piece. So right here at the bottom is where it would slide into that main axle, and then at the top it slides into the earth piece right there. And here's a model of our gears. I originally had some trouble designing the gear, as didn't know how to get the circle shape have each tooth on it, and then I eventually figured it out. And here is the final assembly in Onshape, and I'll just show quick animation for it. So as you can see, the crank turns around using the supports on the base plate, which allows the gear to rotate the second gear on the main axle, which then causes the main axle to rotate, which gives the sense of the Earth rotating around the sun. Here we have our multi-view drawings, is a isometric drawing. And some of the challenges we overcame were during the original design concept and making the gears function as I wanted. I could not figure out how to get the Earth to move around the sun in a circular motion, with the sun remaining still and unmoving. And then eventually I decided to make the Earth part of the sun's rotation and have them move together. Another issue I faced was in the design specifications and 3D printing. I wanted to have an outward facing reaching arm for the Earth. The main axle and the Earth axle I wanted them to be printed together, but the project instructions said not to do this as it would cause a lot of supports needed during 3D printing. And I could not figure out how to get an Earth arm attached when I needed that part of the rotation. And then eventually I came up with the idea of having an insertion point in the main axle for the Earth axle to be put inside and inserted after 3D printing. That way it would not cause any extra supports to be needed. And then again, I also faced issues when I did 3D print. I finished the design as the original Earth sphere and the Sun sphere. The Lego connection plates were too small and did not connect properly to the Lego pieces. So then I had to go back, change the diameters of the connection plates, and then reprint, and then it worked.
This project presents a mechanical model designed to simulate the Earth's orbit around the Sun using a gear-driven mechanism created in Onshape. This assembly consists of a base platform, a vertical axle supporting the Sun, a rotating arm that carries the Earth, and a crank-powered gear system that transfers rotational motion throughout the assembly. When the crank is turned, the gears rotate the main axle, causing the Earth arm to revolve around the Sun and visually represent an orbital cycle. The objective of this project is to apply fundamental CAD skills such as part modeling, assembly constraints, and engineering drawings to create a functioning mechanical representation of planetary motion. This includes generating accurate multi-view and isometric drawings for technical documentation. The final model provides a straightforward interactive demonstration of Earth's orbit while meeting the course requirements for 3D modeling, assemblies, and engineering communication. The model starts with the base platform supports, the main axle with a yellow sun sphere at the very top. A rotating Earth axle attached to the main axle holds the bright Earth sphere. At the very bottom, a set of gears connects to the main axle to a crank. When the crank is turned, the gears rotate the axle, causing the Earth's axle to move in a circular motion around the Sun. Each part of the model, including the gears, axles, spheres, and base, was modeled and created individually on Onshape, and when all are put together, make a working representation of the Earth's orbital movements. The assembly was constructed using a combination of fastened and revolute mates on Onshape. Constructional aspects such as the base, support, and axles were aligned and fixed in place with fastened mates. The main axle and crank were assigned with revolute mates to allow rotational motion. The gear mounted on the main axle and the other on the crank axle were positioned using fastened mates to create a good gear mesh. This mate structure creates a good rotational input from the crank to transfer through the gears and make the orbital motion you see in the Earth being displayed.